So let's go over a little bit of an overview of what we're going to be doing today. Our topic for today is 8.5, adding and subtracting rational expressions. So of course, our objective for today is to add and subtract rational expressions. Some places that you can show me what you know is the exit ticket, the quiz, and the unit test. Those are going to be your three main ways to show me on your grade. All right. A little bit of an overview. We're going to start with some definition work and then going over what a least common multiple is. Then we're going to do some we do practice with the addition method and then with the subtraction. So both of the different ways. And then you'll have a couple of you do problems where you'll do some practice before you actually do your kind of assessment for the exit ticket. Okay. It's kind of a little overview. We're going to start with a little bit of this stuff. So when I'm adding and subtracting rational expressions, again, rational expressions are just two polynomials dividing each other. When I'm adding or subtracting fractions, we must have a common denominator. So hopefully you saw that in today's warm-up. The same rule applies to rational expressions, all right? Which means that we need to make it so that the denominators are the same. Once we do that, then we can add them together. Now, the best way, the most time-efficient way, I'll say it that way, to get the common denominator is using the least common multiple. What's nice about this is that it makes it much easier to cancel things out. All right. So the least common multiple is the product of prime factors raised to the greatest power that occurs in each expression. An example of that is if we had something like, let's say we were checking out things like, let's go 6 and 4. All right. So 6 is equal to 3 times 2. Right? 4, on the other hand, is equal to 2 squared. So when I'm looking at this, based on my definition, I'm going to take all of the factors, and I'm going to only include the one if they're matching with the highest power. Right? So this only has a 2 in this case, and this one has a 2 squared. So in the least common multiple, LCM, I'm going to use a 2 squared. So that's raised to the higher power. And I also have this 3, so I'm also going to multiply it by the 3. Right? Now that we have all that set up, we're going to multiply these out. 2 squared is 4. 4 times 3 is 12. And so my least common multiple between 6 and 4 is 12. Right? One thing to notice is that I had to factor these first before I could actually find my least common multiple. So we're going to be doing the same thing when we're trying to find the least common multiple between two expressions. We're going to factor them as much as they can, and then we're going to do that same process right over here. Right? If we look at this right here, first step over here with A is I'm going to factor this 2x plus 4. What I can see is that they both have a common factor of 2. So I can pull that 2 out front. I'm left over with x plus 2 on the inside. Now with the second one, right over here, we can use our x method. All right? Two numbers that multiply together to get -6 and add to be -1. Again, we can use our x method because we have that invisible 1 out front. That's going to give us -3 and 2. So that's our factored form. Now to go from my factored form to my least common multiple, this one down here, LCM, give myself quite enough room. I take all my different factors. So one of my factors is a 2. So I'll bring that down. Another one of my factors is an x plus 2. Now, this is where it gets a little tricky sometimes, is that I have 2 different x plus 2s in each one of these. I only take the one with the higher power. So since they both have a power of 1, I'll only take one of them. Right? I only need 1. So that's why I wrote this. Skip any overlap between the polynomials. So they have an overlap of x plus 2. So I only use the one with the biggest power, which they happen to be the same, so I only use the first power. And I take that x minus 3 as well. All right, so this is how I get my least common multiple right here. So erase the screen a little bit so we can see a little better. So again, this is my least common multiple. I got it by factoring my two expressions, just like we did with the 2 and the 4, and the 6 and the 4. And then I took my different factors. One factor was the 2. I took that 2 down. One factor was the x minus 3, so I took that down. And then I skipped the duplicate and just put one of them down there. Are there any questions on how we got the least common multiple for A? All right, so now that there doesn't seem to be any questions, I want you all to try and do B right here. You should try and do this problem following the same process. Factor, put together whatever they have in common as one thing. Always taking the biggest power from that, and then putting together anything else that they don't have in common. So try and do B right now on your own. Let me know if you have any questions. I'll be here to help, all that good stuff. All right, so let's go over B now. Clear off our screen. That here. So I'm going to post the first part, the factored forms. So that's what we get if we were to factor these. X plus 4 times x minus 1, x plus 4 times x minus 2, and then x minus 2 times x minus 2, which is also x minus 2 squared. From what it looked like, some of you got the right answer, but you are slightly off in that you forgot the extra x minus 2 in there. Because of the fact that there's 2 of these in one of these problems, the highest power, like this says, the greatest power, is 2. This problem should actually be this answer right here. And if I was writing it fully correctly, I would write it as 90 squared. So this would be your true final answer, because this third one factors into a square on bottom. Now notice that I don't double up on the x plus 4s, because its highest power between these two is a 1, invisible 1 up top. But on the other hand, this one over here has 2, right? Its highest power is 2, so I had to use 2 of them, there and there. So that's how I can kind of think about this, taking that highest power between any matching ones. So there was a matching one between these two. The highest power is the same in each one of these, so I just pick either one. In this case, between these two x minus 2s, this one had a higher power of 2, so I take that one, get x minus 2 squared. Are there any questions on that problem? Any part of B? How we got the least common multiple, how we factored any of these, any of that stuff. That's exactly right. So at that last step right here, I was combining my like x minus 2s into an x minus 2 squared. right, then let's go down into our next problem. Doesn't seem like there's too many questions on it, just that I'm going a little fast, so I'll try and give some people more time. Let's go into our actual thing. So before this right here, finding the least common multiple, we're going to be using that to get our common denominator, right? So that we can combine these, as you can see right here. Because remember, when we add fractions together, we have to have a common denominator. Same thing with subtracting fractions. Right? We gotta get that common denominator. To do that, we're going to follow that same pattern of finding our least common multiple. All right, so again, I factor my denominators right here and here. And then I find my least common multiple by that same process we did above, finding what they have and don't have in common, the x minus 2, putting that there. And then taking whatever they have in common, the x minus 1s, and only taking the highest power one. So each one is the same power, so it doesn't matter which one I choose. And so this will be my least common multiple right here. So again, I choose the denominators to find the least common multiple because of the fact that I want to have a common denominator. This is my process, the first step, being able to get it like this with my fractions as common denominators, right? So that I can then add them together. So to get them now that I have the least common multiple, I'm going to use it by trying to see what I need to multiply the top and bottom of my fraction by to make my denominator match. Again, I'm trying to make my denominator match. I originally had this x minus 1 as my denominator. To get that to match my least common multiple, I need to multiply it by this x minus 2. So I'll multiply top and bottom by x minus 2. All right, once I do that, multiply across, I end up with this right here. This one, on the other hand, already had the same least common multiple. These are already matched with these two, so I don't need to do anything extra. Right? My denominator in this one and the least common multiple match, so this one's already good. This one already give me the common denominator. Are there any questions on what we've done so far for steps 1 or 2? Anybody have any questions for steps 1 and 2 before we move on to 3 and 4? All right, that's one person. Does anybody have any specific questions? Someone asked for me to re-show 2, so I'll do that. Does anybody have any specific questions? All right. So again, what I'm trying to do right here is I'm trying to make my original denominator right here the same between these two. To do that, I need to factor them and then make it the same. To do that, again, I'm using the word to do that a lot, I need to multiply my denominator. Right? So I already have this x minus 1 from my least common multiple. That's checked off. What I need is this x minus 2. I don't have that one yet. Right? So I need to multiply my top and bottom by x minus 2 because my denominator is missing that part. Now, the reason I multiply top and bottom by it is because we are only allowed to multiply things if it doesn't actually change the problem. So if I multiply top and bottom by this is the same as multiplying by 1. And multiplying by 1 doesn't actually change your problem at all. All right, so this is okay. I can do this because this is actually just a 1. Right? Top and bottom, x minus 2. I get this right here. This one already had the x minus 2s and x minus 1. So it already had both of these. So when I'm going my check marks to see which one it has the x minus 1, it has the x minus 2. So we're already good. We don't need to multiply this one by anything. Okay. Once I multiply right across, multiply these two, and I end up with this. Does that answer your question for step 2? So now what I do for step 3, this is probably the easiest step as long as you've done everything else right, is I just combine my two fractions, right? Leave the denominators the same, add the numerators. I get x times x minus 2 plus 2x minus 1. All right. X times x minus 2 plus 2x minus 1 over these. So same thing we did when we add fractions. Now the next step is just simplifying. So I'll distribute the x, get x squared minus 2x plus 2x minus 1, combine some like terms to get x squared minus 1, because these two cancel, and then I do some factoring. So x squared minus 1 is the difference of two squares, and so I get x plus 1 times x minus 1. So now I have it all factored down, and I see that these both have a common factor on top and bottom. So I'm going to cancel these out, cancel and cancel. So this is my first part of my answer right here. Any questions on step 3 or step 4 before we start the finding our variable restrictions? Any questions on that? All right, let's go into step 5. Same process. With step 5, it's the same thing as we did last time. We set our denominators equal to 0, specifically not 0, because we cannot have our denominators be 0, because I cannot divide by 0. Anything divided by 0 is undefined. Excuse me. So I set each one equal to 0, and I solve. Going through the process, factoring like we did, breaking it apart, adding it over, all that good stuff. Just like you know how to do with solving equations. Now there's another way to do this, specifically using the least common multiple. Since the least common multiple is everything on the bottom of my two fractions in the denominator without any repeats, any extras, I can also use my least common multiple set to not equal to 0 and solve that instead, which sometimes, like this one, will actually save us some work. Times x minus 2 does not equal 0. So if I had used my least common multiple in this case, I wouldn't have had to do this part right here, which really in the end isn't that much work, but it does save us a little bit of work. So I could have done it this way using my least common multiple down here, and then factoring and solving. I'm not going to show you how to factor and solve because it is right here. It's kind of pointless. It'll give you x does not equal 1 or 2. Right? But again, notice that these are the same thing because all this is a repeat of x does not equal 1. And a repeat in restrictions doesn't actually matter. Are there any questions on how we label any variable restrictions, how we find our variable restrictions? Are there any questions knowing that you're about to do this on your own in a second? Anything about the process? All right then. Let's work on this one then. I would like you to work on this example right here. Try and follow these same steps. We'll see how you do. That's about it, yeah. I'm gonna give you, let's go 5 minutes this time to try and do this one. As always, I'm here if you need any help. All right, so let's go over the problem now in that 5 minutes. First step we need to do is find our least common multiple. One way to do that is by taking the two things, factoring them down, and seeing what they have in common. So for this first one right here, there's nothing we can really do to simplify this, so we just get 6x squared. You can also think of this 6, if you really want to, as, oops, 3 times 2. All right, and this 4, just like we did earlier, as 2 times 2. Also known as 2 squared. And then we can do that same factoring that we did before with using my 2 squared and my 3 to get my 12. Again, you don't need fully to do this whole part right here. If you can see that it's going to be 12, that's fine with me. I'm just showing you how I got the 12 written out. I did this process in my head as compared to actually written it out. All right. Now, next thing, same thing as we talked about before, we have an x squared and an x. So this one has an x squared, higher power wins. So we take the x squared right here. And then we take the x minus 3 from the second one. Right? So that's how we get our least common multiple right here. From there, we try and make those both denominators. So let's put that part next. To copy this, paste it, Control paste. So again, I start with my problem again. I rewrote it out so that it looks nice. And I have to multiply top and bottom of the first one by whatever it needs to have to match this. So if I want my 6x squared to match this, I need to multiply by 2 and an x minus 3. So 6 times 2 gives me that 12. I already have the x squared, so I'm good on that. But I'm still missing the x minus 3. All right, so check, check, check. All good now. Same thing over here. To make that 4 match the 12, I need to multiply it by 3. And to make this x match this x squared, I need to multiply it by x. Are there any questions on what we've done so far before we move into the next part of the answer? All right. We move on to our next part right here. We multiplied them across, combined them, and made that all into one part right there. Check, check, check. Combine them here, and then it's just a little bit of simplifying. It turns out once I simplified this and put it in standard form, this top part can't be factored. And so we're actually good on that part. 3x squared plus 10x minus 30 is not factorable into a nice number. And so we just have this right here. That's our final answer. Now there's one more thing we need to talk about is our restrictions. To get our restrictions, we take our least common multiple and we set it equal to 0. All right. Go insert equation. And I go 12x squared times x minus 3 does not equal, which is up here, inside the little less than, not equal to, and union, what is that one? Composite, something like that. Can't remember right now. Not equal 0, right? Which means that I break each one into my two things. I'm gonna go this way instead of down because I'm, going off the paper. I get my equation. 12x squared does not equal 0. Space x minus 3. Nice little trick to do this. If you don't want to keep clicking on it, you can copy, and then paste it. Makes it much easier to do things. All right, final step, simplify those, and I get the equation x does not equal 0, and x does not equal 3. So my final answer for this problem, if I was putting it all together, would be this simplified form and this part right here. Because I need both parts to get my final answer. Does anybody have any questions about this problem? Give you a little bit of time to write that down in case you haven't found that chance. Ask me to re-go over how to find the least common multiple. Do that in 1 second. Does anybody else have any other questions? So with the least common multiple, the first thing I need to do is factor it. It's a great question. I'll answer that question as well in a second. So I need to factor this right here. Now this 3 times 2 isn't really necessary. I just like to show it because that's kind of actually how we're finding our least common multiple. You don't actually need to think about that too much. I need 2 numbers that multiply to get 6. So the least common multiple between these two, we already found to be 12. So we can get that from there. But I can also just look at the numbers. So 12 came from 3 times, since this one both have 2's, I go with the higher power, which is 2 squared. 2 squared times 3 equals 12. So that's how I got that 12 out front. I then look at my x's. So I have this x right here and this x right here. I go with the highest power. And so this x squared is higher than this x. So I use x squared right over here. Then I take the other factor that's missing, which is the x minus 3. And I put that over here. So that's how I get my least common multiple. Find my numbers, least common multiple between those, using my factored form, take the higher power between my other ones, put it all together. Does it answer your question for the least common multiple, or do you have more questions on it? Perfect. All right, so someone else asked, how does this equal 0 in the end? I'll show you right now. 12x squared does not equal 0. First step I need to do is I need to divide both sides by 12. What's nice about this one is that when those cancel out, I get 0 divided by 12. 0 divided by anything is just 0. And so that's how I end up with that 0. Square root both sides. Square root, square root. I end up with x does not equal technically the plus or minus of 0. So whenever I square root a square, I have to add that plus or minus out front. It's funny that plus or minus kind of looks like does not equal to, especially when you write it fast like I do. Now plus or minus doesn't actually matter because positive 0 and negative 0 are the exact same thing. They're just 0. So x does not equal 0. That's how I get that. Comes from the fact that 0 divided by 12 is just 0. Are there any other questions on this problem? All right then. Let's change up how I asked. What questions does everybody have? Does everybody understand how we went from here to here and how we got this as the thing that we multiplied this one by? Or how we got 3x over 3x to multiply by this? Does everybody understand that part? Do you understand how I simplified this? How I got this to distribute and everything? Do you know why I put it in this order instead of leaving it like this? Do you understand how I got these two as my answer? Any of those questions? All right, let's move on. We got drawings, exit out. Now, turns out adding and subtracting are pretty much the same thing, specifically because adding by something, so if let's say I add a plus b, subtract a minus b, that's the same as a plus negative b. Right? So I can do that same thing up here. If I really wanted to, I can make this into a plus problem by just making an addition times a negative up here. I can go x plus 2 over x squared minus 2x plus negative x minus 2 over 2x plus 4. Right? And now it's a plus sign. I want everybody to remember that because I think that we get confused on like thinking that plus and minus are some very different things. Realistically, they are the same thing. There's just a little bit of, I just have to do a little bit of pulling around. In the end, though, subtracting is really just adding in the opposite direction. Completely the same. I went through all this problem. I'm not going to go through this one really because of the fact that it's the same process that we already went through up above. The only difference is that I subtract it instead of add it. So I don't think that that's a good use of our time, going through the same process and everything. Instead, what I'm going to do is we're going to skip this example right here. We're not going to do this. And instead, I want you all to start working on the you do problems down below. Okay. We're going to work on these you do problems, these three right here. Once you complete them, I want you to put them in the chat. And once you're done with all three of them, once you've shown me that you know how to do all three, then you can start your exit ticket. I would appreciate it if you did this first so that you know what you're doing. You know that you know. Right? It's very easy to think you know how to do these, like the least common multiple or something, but you don't really know until you start getting hands-on experience. All right, so try these out, put them in the chat, then you can move on to the exit ticket. I'll be here for any questions. Let me know if you need any help.